Thanks for downloading this screencast, part of the series for the Java EE7 launch. This one focuses on the Java API for WebSocket, and I'm going to focus in this screencast on showing you some demo applications and diving into the code a little bit. My name is Danny Coward. I'm the specification lead for the Java API for WebSocket. Now, the first application I want to show you is a little bit like the hello world of WebSocket applications. It's the Echo application. It's a JavaScript client that is running in a browser, and it's going to send a message back to a WebSocket component running in the Java EE7 web container called the Echo server. And the Echo server is going to bounce back a message whenever it receives a message from a browser client back to the client that sent it. And we're going to see, in this case, an annotated endpoint running in the web container. So let's switch over into the code. So here you can see I have a NetBeans project. It's a Java EE project. I have some web pages. I have an index.jsp. This actually contains the JavaScript code that is going to initiate the call. So before we get too deeply into that, let's start the demo. Here we see the index.jsp, and all it is a simple page with a button and a text field on it. Into the text field you can type a message. So let's call it hello screencast. And then when we press this button, it sends a WebSocket message back to the Echo server component, and the Echo server component bounces back a message. And here in the output we can see that first the WebSocket connection is made. Then the WebSocket browser page sends this message, the one that we typed in, to the WebSocket server component. And then we can see in the last line of the output that the browser has received a message back from the Echo server component, which just thanks you for the message and bounces the message back. So now let's take a look at the WebSocket component here. You can see that in the source packages we have the Echo Server Java class. Let's take a look. Now you can see that this looks like a plain Java class with a single method called hi there, which takes a string message parameter and returns a string. You can also see that at the class level it's been annotated with the @server endpoint. This is one of the key annotations in the Java WebSocket API. And this tells the web container that the Echo Server class is a WebSocket component. It is showing here one attribute. The value attribute is set to /echo. This defines the path where the WebSocket component is mapped to in the URL space of the web container. And in fact, this one is being mapped to /echo, which is relative to the context root of the web application that contains this WebSocket component. The second annotation is the @onMessage annotation, which here has been applied to our single hi there method. What this does is it tells the web container that the hi there method is to be called whenever this WebSocket component receives a WebSocket message. And what this method does is return back that incoming WebSocket message and adds to it thanks for the message, as we saw when we saw the demo working. So what you've seen here is a simple, perhaps the simplest WebSocket component that simply bounces back messages, uses two of the most important Java annotations in the Java WebSocket API to turn a plain Java class into a WebSocket component. Now, before we leave this echo example, I wanted to also show you what the equivalent component looks like if we take the second approach that you can choose to create Java WebSocket components. And instead of using annotations, I'm going to show you what this example looks like using the programmatic approach. So I have things set up in a separate application here. I've called it Programmatic Echo Server. Let's run this one first as well. So let's take a look at the Programmatic Echo Server application running. It actually looks pretty much the same as the annotated example. Turning now to the code for this, we can see we have the same web page, just with a different title, of course. But looking at the source code, we can see here the Programmatic Echo Server class. Instead of using any of the annotations from the Java WebSocket API, we're extending a class called Endpoint. This is in the javax.websocket package. There are various lifecycle methods that you can override in this endpoint class. The one that you always have to override is the @onOpen method. This takes a session parameter and something called an endpoint config parameter. The session actually represents the underlying WebSocket network connection, and the endpoint configuration represents the information used to configure this endpoint. Now let's take a look at what's been implemented in this onOpen method. First, to the session, which represents the connection, we add something called a message handler. Now, this message handler is one of the several message handlers in the API that can be used to listen to incoming WebSocket messages. Here we've chosen a particular message handler that will listen to incoming WebSocket messages and turn them into string objects. And it requires you to override the onMessage method, which takes the single message string parameter. Now, in our implementation of the message handler here, what we're doing is getting a handle using the getBasicRemote method on the session object. We're getting a handle to the remote endpoint on which we can send WebSocket messages. Here we've chosen to send a text message in the form of a string object. You can see the sendText method being called, passing in the thanks for the message concatenated with the text parameter. And you can see that we have some exception handling here to do. Obviously in the real world we do a little bit more than simply print something out to the console, but this is just a demo application. So this is showing you that, equivalent to the annotated example, you can take a programmatic approach to bounce back incoming text messages from this programmatic example. The second method that we override here, the onError method, also takes the session, which represents the connection, and also takes a throwable parameter. Now what the onError method does is that whenever the WebSocket component encounters some error, perhaps there's an error on the incoming message, it's too big, the format can't be decoded, or perhaps one of the other lifecycle methods on the WebSocket itself throws some error. The onError method is always called with this error and gives you an opportunity to handle the message, to log it, or to take some remedial action to deal with it. What we just saw in this application was a simple JavaScript client speaking back to a WebSocket component deployed in the web container, just as a regular Java EE application with no special deployment descriptor or configuration. In one version we saw an annotated WebSocket, and in the other version we saw a programmatic WebSocket endpoint. Each approach is equally valid. Now let's move to the second application I wanted to show you. This is a simple chat application. And what I'm going to show you is something a little bit more sophisticated, where instead of sending simple string messages, we're going to send custom Java objects as WebSocket messages. And I'm also going to show you, in addition to a browser client, a rich Java client to our chat application. So let's take a look at the demo. So here's the application here in our project called Multi-Chat Client. Let's take a look. Again, we have a web page which contains the JavaScript code that's going to run the application. So let's run it. Here we can see a traditional kind of chat window. I'm going to sign in here as myself. And here we can see on the left-hand side the chat transcript. So if I say something here, hi there, it shows up on the chat transcript. And on the right-hand side, this list here is showing me everyone that's logged into the chat room. Well, this is a pretty sad chat room at the moment because there's just me in it. Let's add someone else. You'll notice here I'm using the Safari browser. Let's fire up Google Chrome and let's log into the chat application there. Here we see the same chat sign-in screen. So let's log in as my friend Ian. And now you can see that Ian has just joined over here using Google Chrome, and he can also say something. Now if I go back to my Safari client here, I can see that Ian has been added to the users list, and when Ian said something, my chat transcript logged in as Danny over here has also updated. So this is a traditional chat application. We're all fairly familiar with them. Now here we can see all of our chat clients. If I just arrange them a little more cleanly, I have my Safari chat client, I have my Google Chrome chat client. Now over here I have a Java Swing chat client. So let's sign in as Duke over here. And now we can see that everybody's user list has updated to show that I have Ian, Danny, and Duke logged in, and Duke can go ahead and chat. And Duke can also notice that Danny is going to sign out now because we're going to take a look at some of the code. Now let's take a look at some of the code that makes all that work. First, we'll take a look at the chat server component. This is a plain Java class that's using annotations from the Java WebSocket API to turn it into a Java WebSocket component. Now we can see, unlike the Echo server example, it uses a more sophisticated form of the server endpoint annotation in that it's using more attributes on it. We've mapped this endpoint to a different URL, to /chat server. Again, this is considered relative to the context root of the web application containing this endpoint. We're using here something called a subprotocol. We've named it chat because this is a chat application. WebSocket subprotocols are a way of tagging particular message formats and choreographies of message interactions into something it calls a subprotocol, which is that particular arrangement of formats and message choreographies. Here, for example, we're expecting chat messages, we're expecting a new chat message to be followed by a transcript update and an update in the user list. So this subprotocol really is being used to encapsulate those particular aspects of this application. We'll see, and I'll show you why later, we've listed a decoder called a chat decoder and an encoder called a chat encoder, and we're using a chat server configurator class. I'll take you through what each of those means as we look through the code. Now the first thing we'll look for is the @onMessage call. This has been applied to the handle chat message method. Now you'll notice that the handle chat message method takes a chat message object. The chat message object encapsulates all the data that's being sent in this application when a user signs in, when a user sends a chat message, when the transcript is being updated on all the connected clients, and when the user list is being updated on all the connected clients. So inside the implementation here, the first thing we're doing with this chat message object is determining its type, and then using its type to know how to deal with this incoming message. Now you may be wondering how the incoming WebSocket message is being turned into the chat message. Well, that's where our chat decoder that we were listing in the server endpoint annotation comes in. Let's take a little quick look at that one. The chat decoder is over here, and what it does is it implements an interface from the Java WebSocket API called the decoder text interface. Now this interface defines a little application protocol that says this is the kind of component that knows how to turn a string object into a chat message object. And the container will call this whenever a message comes in that's a text message, and will attempt to use this decoder to turn that into a chat message object. And that is in fact how the chat server, the handle chat message, can be written with a chat message object as a parameter instead of one of the native WebSocket formats, string or byte array or byte buffer. Let's take a little look at how this component broadcasts an update to the user list. So if we move further down, we can see that when a new user signs in, we're calling this process new user method. So let's go and take a look at that. Here's the process new user method. It takes the new user chat message that was dispatched from the @onMessage method. The first thing it does is to validate the username. It's no use having a chat application that allows two people to have the same name. So it will create a unique one for each new user. Then I wanted to draw your attention here to this use of the session object. You remember the session object represents the underlying connection. Here we obtain the remote endpoint from the session object, which represents the connected client. And we're sending it an object. This uMessage parameter, which you'll see 2 lines above, is the new user message. So this is broadcasting the confirmation to that client that applied to sign in that they have been successful, and is assigning them the username. And we can see lower down, we will also step into this method, the broadcast user list update method, because now that our new user has signed in, we need to tell everyone else that a new user has joined. So let's take a look at that one. So we can see here that the first thing we do before we broadcast this new user's arrival is to create another kind of chat message, which is going to contain the complete user list of everybody that's signed in. Then we're going to iterate through this set here, the session.openGetOpenSessions set. This is a very useful method for broadcasting WebSocket messages to all connected clients. This method will list all the open connections to a WebSocket endpoint. Here we're using it to broadcast this update to the user list to all our connected clients, so everyone knows that a new user has logged in. And with each connected session, again, we get the remote endpoint and send it the object using the send object method called here, passing in the chat message object. Again, you might be wondering, well, how can we send chat message objects as WebSocket messages? Who's doing the encoding? And we'll see that rather like mirroring the decoders, in the class level server endpoint annotation, we configured an encoder to encode chat message objects into WebSocket messages that can be sent along the connection. So now, to summarize what we've just seen, I'll switch back to the presentation. So what we saw in this demo was a browser client actually running in both Safari and Chrome equally well, with no difference in how it was written on the back end. We were sending and receiving custom Java objects, and I showed you a little bit of the encoding and decoding scheme. And I also showed you the rich client API version that you can use to create rich clients in parallel with browser clients to your WebSocket components. Now, to wrap up here, I'll thank you for listening. The Java WebSocket API is part of the Java EE7 SDK, part of Glassfish. To find out more information about Glassfish, these are some excellent resources by which to do so. Thank you.